Okay, so describe relationship between definite integral and net area. So in net area, you'd be looking at, I'm going to clear up, if you have something above and below the curve, you would subtract what's above from what's above minus what's below, because below is negative area and above is positive area, and that's what they call the net signed area. So example here, you have stuff above, stuff below, and you would subtract to get the net area. Here's a nicer picture here. So nice smooth thing, you would subtract. Oh, it looks to me like area 2 is bigger than area 1, so it'd be negative in the end. So here's an example. Find the net signed area between the curve of the function f of x equals 2x and the x-axis over the interval from -3 to 3. So if I draw that, it's going to look something like this. And it's going from -3 to 3. So that's going down to be down to like -6. And this would be coming up to +6. I'm going to call this, I was doing this a little different than the book was. I call this down here area 1 and call this area 2. It doesn't matter what you call it. But in essence, we have to do area 1 minus area 2 because that's below the area 2 minus area 1. Because we're taking away the negative area. And so what is the area of this? If this is 6 by -3, -6 by -3, what is this? What's the area? Area 1 is going to be 1/2 of 3 times 6, which is 18. But it's down below, so we're taking it away. Area 2 is similar. It's going to be 1/2 of 3 times 6. No, that's not 18, that's 9, which is 9. So area 2, which is 9, minus area 1, which is 9, comes out to be what? 0. So if we were looking at the integral from -3 to 3 of 2x dx, we would be looking at our area 2 minus area 1, which was 0.
Did you get the 1/2 part?
Area of a triangle. One half base times height. Okay, so that's not so bad, I think. I mean, a lot of these are going to be solving them with regular old area formulas. Usually are going to be triangles. So the next one, what's a little bit different about this one is that it's not the same size. So you're going to have a net area that's not going to be 0. If we were to take this 6 and plug it in here, we get the 4. So that's why this height here is 4. We put in the 0, we get down here at -2. So if we have this one, they call this area 1, that area 2. So they want area 1 minus area 2. What's your calculation here for area 1? So we want base. What's the base of our triangle? From 2 to 6 is how far? 4. So 1/2 times 4 times, and the height is what? 4. So that's going to be 4. No, it's going to be 8. And our area 2 is going to be 1/2 of, it's 2 across and 2 down. So 2 times 2. So that's going to be 2. So our integral from 0 to 6 of x minus 2 dx is going to be 8 minus 2, which is 6. So that's net area. And next we're going to talk about total area. The concept of total area. So net area, we just subtract them. In total area, the difference is we take the absolute value and get rid of the negative. So in a case like this, our total area would be the top plus the bottom. We've taken absolute value, so there's nothing negative down below. So our definition is the total area is the absolute value of f of x dx. So integral from a to b of the absolute value of f of x dx. So it's a1 plus a2. So with that, what would our total area be for f of x equals x minus 2 on the interval from 0 to 6? So if we're to draw a picture of that, if I put a 0 in there, it's at -2. And it looks like it's going to cross at 2 and go up as high as 4. There. So we want the area under the curve here and here, but we want total area. So our integral from 0 to 6 of f of x, or I'll just say x minus 2 dx, it's going to be area 1 plus area 2. So this area over here, this is a distance of 4. Like we just did this. Yeah, well, this is the last problem we did. This is 4. So this has an area 1 equals 8. This has an area 2 of 2. So it's going to be 8 plus 2, which is what? 10, yeah. Almost feel like that insults your intelligence a little bit. And the last one we're going to look at, I made one slight mistake. I needed to change these parentheses to an absolute value. Oh, man. I just lost it all. 0 to 6 of the absolute value of x minus 2 dx. Okay. The last one refers back to the first problem we did that had the 2x from -3 to 3. So if you recall on this one, graph was something like this. That's 3. This is -3. This area had I called it area 1, but they called it area, whatever. Area 1 is 3 as a 9. Area 2 is 9. So our integral from -3 to 3 of the absolute value of 2x dx is going to be area 1 plus area 2, which is going to be 9 plus 9, which is what? 18, yeah. Yes?
How did you get the areas? What was the formula?
Formula for area of a triangle is 1/2 of base times height. So this had a base of 3 and a height of 6. And this is a problem we did earlier. I just referencing back to it. So 1/2 of 3 times 6 is half of 18, which is 9. It's the same thing down here. This goes down to -9.
So I know the base because it tells me, right, for 3, and then
Yeah.
I'm plugging that in.
Plug that in
to find
to here to find the height. Yeah. So that's 6. I should say this is -6, not 9.